back. This is the Tutor Wizard. I'm Adrian. Please subscribe right here. You'll get notifications for this series and many more on our channel. Today what we're doing is part 2 of the Super Mario Math. Basically what we did last time was we looked at with the math you needed inside a level in world 1, 3, 5, or 6 to turn a wandering hammer brother into a white ghost ship. What we're going to do today is we're going to go inside the ghost ship and count a bunch of coins and do a bunch of other mathematical counting. Let's go do that. Alright, so here's the big reveal. If you've never been in the white ghost ship, I don't know why it's a ghost ship still, but that's what my brother and I call it, so we're sticking to it. If you haven't been in this white ship, what happened was, you saw last time we turned the hammer brother into that ghost ship. Now we're going to go inside there, and coincidentally, as I was finishing the other 2 levels I had to use to get there, usually I have to finish 5 and 6 and he stays here, but for some reason it moved out here. So yay, I'd never seen that happen before. Now you're my witnesses. Let's do it. What's inside? It's not a ghost ship, it's a bunch of coins. How many coins are there? We're going to go downstairs in a second and count, but for now, let's get them all. So I'm going to quickly, this is how I make sure I don't miss any of them. So coincidentally, I think in that first section right there, there was 88 coins, and Mario 3 came out in 1988. And then there's some more coins over here on these 3 ladders. I just counted them, but if we stop even there, how many did I get? I don't know. We're going to have to count them all downstairs. And then I think this is the last clever section. And then this is the one I wanted to talk about right here. This is what we call it. The Greeks did this first, but in math we call this a triangle number. So the first triangle number is T1, and there's 1 dot in the array, or coin in the array. T2, the second triangle number, has 3 dots in the array, then 6 dots, then 10. So this is T4, which has 10 coins or 10 dots in a triangle number. So there's 10 coins right there, 10. And then what's in here? I don't know. Oh. Then we go in here. You have to fight these 2 hammer brother guys. They're going to try and get me with their boomerangs. They're boomerang, not hammer brothers. But you get the same prize as you would have got with the hammer brother. There. Now you've seen inside the white ghost ship. Let's go count some coins. Coming up. Play some more. We can do it again. Yeah, it's good. Do some Mario Math? I know, let's go do some Mario Math. Let's go do it. Let's go! Okay, so now you've seen in the ghost ship, we went through and played, and I grabbed all the coins and I killed the 2 boomerang brothers, or instead of hammer brothers, they're boomerang brothers. What we want to do now is, and what I made my daughter, I did this for elementary grade 6 kids this year also, and what we made them do after was count all the coins, like, oh, math and stuff. So yeah, this is the math that's in this video, is just counting all the coins. In particular, I want to talk about some triangle numbers. In the first block, so here's the white ghost ship. In that white ghost ship, what we have is in the first block, it looks like there's 88 coins. And I'm pretty sure it's because, like I said in the other shot, basically I think that he picked 88 because it was released in 1988. In the second block, though, there's a few, and if you're going to count them, he liked to put them a lot of the time in blocks of 10, so 2 by 5. So this is a good way to count them. And if you look in a lot of the sections where he's put them in groups of 10, so you can count them fairly quickly. In the first block, he put 88 for the year it was released. In the second block, he has, I think, 40 and 30 coins. And then he has this array, and this is really what I wanted to talk about, was these triangle numbers. So at the very end of the white coin ship, there is this array, and I don't know if they knew this at all, but what the Greeks were interested in was figurative numbers. This is one of the examples. These are called the triangle numbers, but basically what the Greeks were interested in, numbers that were associated to geometric arrays. The triangle numbers or square numbers or pentagonal numbers or hexagonal numbers or oblong numbers. We're going to do another video on those ones, and you can check it out by subscribing right here, and you'll get a link to those. You have to hit the bell, apparently, not just a subscription, hit the bell also, and you'll get notifications to this series and many more. What are the triangle numbers? Triangle numbers are basically, what we're going to do is this. T1 is just going to be one row or one column in a triangle. And then in the next one, if I make a triangle with 2 rows or 2 columns, then this will be triangle number 2, and there's 3 coins in it. And then if I use the next one, it has to be one higher than the next one. So how many coins are in this one? And I wanted to know, they would call this a triangle number. This is T3, the triangle number 3. And how many are there? 1 plus 2 plus 3 is 6. 6 is perfect, coincidentally. He's the product. 3 times 2 times 1 is 6, and 1 plus 2 plus 3 is 6, also coins, Marion coins. So the third triangle number is 6. What's the next triangle number? Well, we add 4 coins to that one, and we're going to get 10. And what's the next one going to be, and how many coins am I going to have to add? 1, 2, 3, steal you guys. 4, 5, that's T5. How many are in there? 15. So this is what we call the triangle number T5, and T5 is 15. And this starts creating a sequence, and this is where I can't stop myself and I can't shut up about math. T1 was 1, and T2 was 3, and T3 was 6, and T4 was 10, and T5 was 15, and T6 is going to be what? Tn, it turns out, is the sum from I equals 1 to I know of I, which means what? This is 1 plus 2 plus n. And that turns out to be, Carl Friedrich Gauss proves this when he's 5 years old. So yeah, you better start doing some math. This is n plus 1 over 2. So in that calculation, we now know that if I want T6, this is 6 plus 1 over 2, which is 6 divided by 2 is 3. Don't multiply the top ones to get 42. I know I really like 42. It's the meaning of the universe and everything, but don't do that. I divide the 6 and the 2, and then I multiply by 7, which gives me 21. T6 is 21. Please subscribe and hit the bell. You'll get notifications for this series and many more. Next time, what we're going to do is not in this spade one, but the wandering spade card that comes with the memory game. What we're going to do is we're going to look at how many different configurations are there in that memory game. I've got a bunch of cheat sheets. There's all the memory games. I've already planned them all out. That's what we're going to do next time. You're like, gotta record.
Keep going.
I always wanted to do the first one.